rainfall monitoring based on Android application. Before that, let us introduce ourselves. William Muhammad Aladin Device Darjo, Farafi Korganto, Imade Prabawa Sandi Gotama, Iqbal Farhan Sariduan, and Muhammad Arya Bintang Pratama. This is the list of contents. Number one is background, problem formulation, objective, theoretical study, tools, schematic discussion, and conclusion. I will explain about background. High rainfall in Indonesia often causes flooding and other disasters, so real-time rainfall monitoring is essential for disaster mitigation. Traditional methods, such as manual rain gauge, require human labor and are often less efficient, especially in remote areas. By development of new technology, an Android application-based rainfall monitoring system is very promising given a more effective, fast, and affordable solution. The purpose, monitoring rainfall in real time. Build a system that can automatically monitor rainfall and send real time data to users. Improve measurement efficiency. Reduce reliance on manual measurement methods by using automated sensors that are more accurate and efficient. Provide easy access to information. Develop a user friendly Android application so that the public, supervisors, and government can access rainfall data from various locations easily through mobile devices, reducing manufacturing costs, designing a cost-effective rainfall monitoring tool without sacrificing the quality, which can be implemented in various regions, especially those with limited resources. Increase public awareness about the importance of rainfall monitoring and the impact of weather changes, and provide information needed for disaster risk mitigation. Okay, next about the theoretical study formula. So we can see in this presentation that have three pattern. The first pattern is about rainwater volume. V equal L per H. That's its height of rainfall. L is surface area and V is volume. And then the second pattern, there is a rainwater height that the pattern is H equal V per L. That means is its equal height is rainfall and L is surface area and V is volume. And the third, there is circle area. Pattern is P point R quadrat, that R is circle radius. And then about the ESP8266, the ESP8266 is a microcontroller with integrated Wi-Fi that ideal for IoT application using the Tensilica L106 processor. The ESP8266 allows wireless data collection, processing, and sending. Working principle: the saving sensor input, processing it, and sending data to the server via a Wi-Fi connection. And the second one, there is I2C. I2C is a serial communication protocol using two pins, SDA and SCL. One master device can communicate with many select devices. The master controls the clock or SCL and the send or receive data via SDA, allowing device communication with low power consumption and minimal complexity.
There is a red switch. A red switch is a mechanical switch that does not require external power, activated by a magnetic field. The sensor consists of two metal blades inside a separate glass tube. Two operating states are normally open in NO, which closes when a magnet is present, and normally close NC, which open when a magnet is present. Okay, next, there is Flutter. Flutter is Google's SDK for cross-platform app development using the Dart language. Flutter builds UIs with customizable widgets. How it works: Flutter renders the interface directly to native code, resulting in high performance, responsive apps for multiple platforms. There is MySQL is a relational database management system. system based on SQL. The working principle stores data in structured tables and provides access through queries such as select, insert, and update. MySQL uses primary keys for unique data identification and relationships between tables for organized management. And next, XM, XM is a software package containing a page or web server. MySQL for database, PHP, and Perl. Working principle providing a local server environment for web application development. A page server HTTP request. MySQL stores data in PHP runs straight on the server side locally. Okay, next.
To schematic, first is block diagram. In this input, we use red switch. In process, we use ESP8299, and the output will be on LCD and Android application. Next, this our tool schema. We will use red switch sensor, ESP, and LCD. Is tool design. This is our 3D design that will use diameter 50 centimeter.
Okay, so based on calculation between circle area and rainwater volume, we get our tipping bucket resolution is around 0.2 millimeter. So this is showing between hardware and software interface. On the left side, we're using LCD by using A2C communication connect to hardware and showing that there is connect to Wi-Fi nodes. And the second picture is showing when during Wi-Fi disconnect, and another picture showing our Android apps interface. So we're using two schema for testing, but the testing was repeated 5 times by pouring 5 milliliters, 10 and 15 and 25 milliliter into the tipping bucket. And the two schema tests, the first schema is we using slow pouring, which is pouring water for 30 seconds, and then fast pouring tip is pouring water for 10 seconds. So this is our result. We using a linear regression model for analyzing the correlation between X and Y value during slow simulation tests. We get a strong number around 98.85% correlation. This is so high number of correlation that we get. So this is our correlation in phase simulation tests. We get high numbers too, with approximately around 99.26% of variation in Y. So the conclusion that we get, this project result in an IoT-based rainfall measurement system with a resolution of 2.1 millimeter per 3.x milliliter tips. And then rainfall data is sent in real time to an Android apps, enabling easy and quick monitoring. And last, the system provides a solution to monitor weather condition and support data-driven decision making.
Maybe that's all the presentation from our group. Sorry if there are any wrong word and action. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.